In the second tutorial, we will rewrite trinomials into factored form. So let's flip over to problem number 4 in our notes, and now we will be factoring our expressions by grouping. When we learned how to group in a previous tutorial, we grouped when there were 4 terms. But clearly these are trinomials, so there are only 3 terms. What we need to do is we need to make this middle term split into 2 other terms so that we have 4 total terms. And this is how we're going to do that. We're going to take the first coefficient, which is 5. We're going to take the last coefficient, which is 6. We're going to multiply those two numbers together, and we're going to get positive 30. Now we need to factor that 30. We need to find all of the pairs of numbers that multiply to give 30. Let's go in order so we don't forget any. I know that 1 times 30 makes 30. I know that 2 goes in 15 times. I know that 3 goes in. It goes in 10 times. 3 times 10 is 30. 4 does not go into 30 evenly, so let's skip 4 and let's go to 5. 5 times 6, and I believe that's it because the next number would be 6, and I've already used that. These are the 4 pairs of numbers that multiply to give 30. I need to find the one pair of numbers that will help me get negative 13. I know that 3 and 10 make positive 13, but I need negative 13. What if I make them negative 3 and negative 10? It's okay because negative 3 times negative 10 is still positive 30, but they also add up to make negative 13. So that's the pair of numbers that I want. I'm going to take negative 13x and I'm going to separate it into negative 3x and negative 10x because they mean the same thing. And now I see 1, 2, 3, 4 terms. Let's rewrite all 4 terms. I've got 5x squared. That's my first term. My middle term is now 2 terms, negative 3x and negative 10x. And my last term, of course, is still 6. Now I have 4 terms, and I can do my factor by grouping. I'm going to group the first 2 terms together, and I'm going to take out my GCF. I believe that that's an x. If I factor out an x from both of those terms, I will be left with 5x from the first term, a minus sign, and 3 from the second term. Okay? And now I move to the second grouping. I'll group the last 2 terms together. I see a 10 and a 6, so I'm going to take out a 2. But be careful. It starts with a negative. So if I take out a 2, I'm going to be taking out a negative 2. And you always have to watch out when you're dividing out a negative. Negative 10x divided by negative 2 makes positive 5x. And positive 6 divided by negative 2 makes negative 3. This is where I stop and make sure that I am correct. If I am correct, then the 2 sets of parentheses should be exactly the same. And they are. And since they're exactly the same, they are common. And if they are common, I can factor them out as a GCF so that 5x minus 3 can be factored out, and what will remain will go in this set of parentheses. This factor of x from the blue term, and this factor of negative 2 from the brown term. And now that I'm finished, I factored that trinomial. Let's do number 5 and see how these two problems compare. We have another trinomial, which means I need to split up the middle term into 2 parts. To find those parts, I need to take the first coefficient, which is 1, and the last coefficient, which is negative 30, multiply them together, and I get negative 30. Very similar to our positive 30 over here, except that it's negative, which means that it's going to be the same numbers, but one in each pair has to be a negative. So let's list them. I'll just put the first one as negative. Negative 1 times 30, negative 2 times 15, negative 3 times 10, and negative 5 times 6. One of the numbers has to be negative, but not both. Now I need to find the pair of numbers that's going to make a negative 13. But this time the 3 and the 10 don't work because it's not a 3 and a 10. It's a negative 3 and a 10. That makes 7. That's not going to help us. It's actually the negative 2 and the 15 that will help us. It's close. This actually adds up to be positive 13. But if I change the negative 2 to a positive 2 and the positive 15 to a negative 15, that will make negative 13. And that's the pair of numbers that I need. I'm going to take the negative 13xy and rewrite it as a 2xy minus a 15xy. The variables just go with the numbers. Let's rewrite all four of our terms. Our first term is x squared. Our middle term is now two terms, positive 2xy and negative 15xy. And our last term is negative 30y squared. Now I have all four of my terms, and I can do my factor by grouping. I'm going to group my first two terms together. What's common here is just an x. I'm going to pull out an x from those two terms. X squared divided by x becomes x. I see a plus sign come down. 2xy, if I take out the x, I'll be left with the 2 and the y. Okay, and let's group my next two terms together. This is also leading with a negative, so I know I'm going to be factoring out a negative. I see 15 and 30. What goes into both of those is 15. I see an x and a y squared. Well, y must be common, so I'm going to pull out a y. And let's see what's left. Now, if you want to divide and actually see the negative 15y here and the negative 15y here, that absolutely is great. It helps. Negative 15xy divided by negative 15y would be a positive x. And a negative 30y squared divided by a negative 15y becomes a positive 2y. This is where I stop and check and make sure that I'm correct. My parentheses have to be identical, which they are, which means that I can take them and factor them out as one set of parentheses, x plus 2y, and the other set of parentheses will be what's left when I take that the x plus 2y out. I'll have the x from this term and the negative 15y from this term. And I factored another trinomial. Let's go back and look at numbers 2 and 3 above and see if we could actually do more in those problems. I pulled out a GCF in number 2 already, but there's a trinomial that's left. I wonder if I can factor this trinomial. If I can, let's see. If I take the first coefficient, which is 1, and the last coefficient, which is 1, and multiply them together, I get 1. Well, the only way to get 1 is just 1 times 1. So there's only one pair of numbers. And unfortunately, that pair of numbers is not going to help us get negative 4. So that must mean that this trinomial cannot factor anymore. And pulling out the GCF must have been all that we could do. So I'm just going to circle that. That's all that we can do in this problem. But let's look at number 3. We also factored out a GCF, but just because you factor out a GCF does not mean that you're finished. Look at what's left, a trinomial. I wonder if this trinomial can factor. Let's take the leading term, or the leading coefficient, which is 1, and the last coefficient, which is 6. Let's multiply them together, and 1 times 6, of course, is 6. The factors of 6 are 1 and 6, and 2 and 3. I wonder if any of those pairs of numbers can help me get a 5. Well, 2 plus 3 makes 5, so that pair is going to help me. And this must be able to be factored. So I'm going to take the 5x and make it 2x plus 3x. And let's see what we've got now. Now, I already have this GCF out here, so let's not be confused by that. That's just going to always remain outside. And I'm going to introduce a bracket. Since I'm going to have parentheses, let's just introduce a bracket here. I've got my first term, which is x squared, and my middle terms are now going to be 2x and 3x. And my last term, of course, is a 6. So there's my bracket. Now let's do our grouping. We've done this a bunch of times now by now. Group the first two terms together. Don't forget the negative 3. I'll just leave that right there. And I'm going to have the bracket. I'm going to pull out an x from the first two terms, and I'm left with x plus 2. The second two terms, I see a 3 and a 6. I'm going to pull out a 3. And since it starts with a positive, I pull it out as a positive 3. And let's see what's left. 3x divided by 3 is x. 6 divided by 3 is 2. I know that I'm correct because I have the same set of parentheses. So I can go straight to my answer. Don't forget that the negative 3 is always out here, and it's going to remain. I got my factor of x plus 2, and then I've got my factor of x plus 3. So what I wanted to show you here is sometimes pulling out a GCF is all you can do. For number 1 and number 2, that's all that we could do. But in number 3, when we pulled out a GCF, we were left with a trinomial that actually could factor more. And you always want to factor completely. Okay, and I've got one more problem to show you. Factor by grouping. Let's do number 6. I've got 24x squared plus 22x plus 4. Well, you know, as I said those numbers, some bells went off in my head. They are all even numbers, which means that there must be a GCF. And you always want to look for a GCF first. It just makes the process easier. So always look for a GCF. I believe that 2 is the biggest number that goes into all three of these numbers. So I'm going to divide all of them by 2. Now the 2 does not magically disappear, of course not. It comes out here and we introduce a set of parentheses to see what's left. We would have 12x squared, 11x, and 2. This 2 will remain in our problem all the way down to the end, so please don't forget about that. But what's left is another trinomial. I wonder if that factors. Let's try. We'll take the first coefficient, we'll take the last coefficient, we'll multiply them together and we'll get 24. Let's find the factors of 24. 1 times 24, 2 times 12, 3 goes in, it goes 8 times, 4 goes in, it goes 6 times, 5 does not go in, 6 goes in, but I've already got the 6. So it looks like we have 4 pairs of numbers again. Which pair of numbers is going to help me get 11 today? Well, that doesn't. Oh, 3 and 8. 3 and 8 add up to 11. So that means that that's the pair of numbers that I need. 11x is going to separate into 3x and 8x. All right, let's see what we've got. I'm going to keep this 2 out, and I'm going to introduce that bracket. I've got my 12x squared, that's my first term. My 3x and my 8x will go in the middle, and my 2 will go at the end. Now some people might ask, does it matter if you put 3x and then 8x, or if you put 8x and then 3x? And the answer is no, it does not matter the order. You will get the final answer that is the same. There's only one way to factor this correctly. So if you want to separate this into 8x and 3x and try it that way, that would be great. Okay, let's do our grouping. I've got the 2 out here, and I've got my bracket. Let's see, 12 and 3, I can pull out a 3, and x squared and x, I can pull out an x. And let's see what's left. 12x squared divided by 3x becomes 4x. Maybe you want to divide by 3x so you actually see it, divide by 3x so you actually see it. That's absolutely fine. 3x divided by 3x, well, that becomes a 1. Don't forget, if you pull a GCF out of 2 things, there will be 2 things remaining, even if it's just a simple little 1. Okay, and let's group these last 2 terms together. I've got 8x and 2. I can pull out a 2, and it's a positive that I want to start with, so a positive 2. If I divide this by 2, I get 4x, and if I divide 2 by 2, of course I get 1 with a plus sign in the middle. Hey, look, my parentheses are exactly the same, so I must be on the right track here. I can go straight to my answer. The 2 is going to be the first thing I write. My set of parentheses, 4x plus 1. And then my 3x plus 2 will be in the other set of parentheses. So there are a bunch of trinomials that we just factored using the grouping method. I encourage you to watch this video, and I'll see you in class. We'll practice this some more. Thank you. See ya.